I'd like you to take a moment and read through problem number 6. Water's flowing from a shallow conical reservoir. Okay, that just means I've got a cone. There's water inside here, and the water is draining out. I know that the volume of a cone is 1/3 pi r squared h. I'm going to leave a space over there. There's more I'm going to do there in a moment. Well, actually, you know what? I should probably fill in the rate that I was given. Water is flowing at a rate of 50 meters cubed per minute. Okay, that 50 meters cubed per minute, d what dt? Hopefully you said dv dt. I know that dv dt is, and if water is flowing out of this thing, that means I'm going to make it negative 50 meters cubed per minute. How fast is the water level falling when the water is 5 meters deep? I think I want to find, well, what do I want to find? The rate of change of the water level is d what dt? I want to find dh dt when h equals 5 meters. Now, I was told the tank has a radius of 45 and a height of 6. I know that this dimension over here is 45 meters, and I know that the height of my tank is 6 meters. But what you need to realize is there's really two cones going on here. The cone of that entire tank, but then also my cone of water. And that cone of water has a radius that's changing and a height that's changing as it drips out. I'm going to say that the radius of my cone of water is r, and the height of my cone of water is h. Like the last problem, I have too many variables over here. I need to figure out something for r or figure out something for h, but I can't plug in 45, nor can I plug in 6, because those are not really talking about the cone of water, which is really what I'm dealing with. Both the radius and the height of that cone of water, those things are changing. Here's the trick that I can use, though. Let me look at a cross-section here. Here's a cross-section of the cone. Here's the cross-section of my water. The cross-section of the entire tank has a radius that's 45 meters and a height that's 6 meters. The cross-section of my water has a radius of r and a height of h. What we should realize is these two cones, and therefore these two cross-sections, are similar. We can form some ratios out of them. These triangles are going to be similar. There are several ways I could set up my ratio. I could say r over 45 equals h over 6, or 45 over 6 equals r over h, or some version of that. How about I go with r over 45 equals h over 6? Why not? Now, I'm going to do what I did in my last problem, and I'm going to solve for one of my variables so I can plug in here. By the time I'm done, what variable do I want in this equation? Do I want h's left in there, or do I want r's left in there? Well, since I want to find dh dt when h is a particular height, I think I want h's in this problem. Which means I need to take this thing and I need to solve it for what? For r or for h? I need to solve this one for r, so I can then plug that in over here and get something with just h's in it by the time I'm done. I'm going to multiply both sides by 45, and I'm going to get r equals 45h over 6. If you don't like that, you could also just cross multiply and then solve. I might as well simplify, though, my 45 over 6. I know I can divide them both by 3, so how about 15 over 2h? I'd like you now to take a moment, plug that in where the r is, and clean up this equation so it becomes something that just has h's in it. v equals 225 pi over 12, although I am going to want to simplify that. The more simplifying we can do along the way, the better off we're going to be. I know I can divide 225 and 12 by 3. So that's going to give me 75 pi over 4 h cubed. I don't think there's anything new in the rest of this problem. So how about you take a few moments, see if you can finish this off. Do your part 3 where you get your formula for dv dt and then plug in negative 50. And then go do your part 4 when you plug in your specific height. Okay, so dv dt is going to equal 75 pi over 4 times 3h squared dh dt. dv dt is going to equal, let's see, 75 times 3 should give me 225 pi over 4 h squared dh dt. Probably time for me to move up a little bit. I'm going to plug in my negative 50. Negative 50 equals 225 pi over 4 h squared dh dt. Going on to part 4 where I plug in my specific instant. Negative 50 equals 225 pi over 4 times 5 squared dh dt. Just going on a calculator at this point. 5 squared is 25. 25 times 225 will give me 5,625 pi over 4 dh dt. Multiply by the reciprocal, negative 50 times 4 over 5,625 pi equals dh dt. Let's see, then just some simplifying here. dh dt is going to equal negative 200 over 5,625 pi. I'm going to simplify that. I'm just going to cheat and use the calculator. By the way, when we have a test on this, it will be fully with a calculator. I've got negative 8 over 225 pi, and my units are going to be not feet, but looks like meters per minute. And please make sure when you're doing this, no non-standard abbreviations. M is the abbreviation for meters. MIN is the abbreviation for minutes. Definitely don't say that minutes is like M or something. M/M wouldn't make any sense for the units. Meters per minute. In the next couple videos, we're going to look at some other versions. All the related rate problems we've dealt with so far have involved either areas changing or volumes changing. We're going to look at things changing in other contexts in a moment.